last topic for today is about physical data layout. We'll talk about table spaces and directories, about files and data pages, about forks, and about toast, the oversized attribute storage technique. What is a table space? Table space is basically a directory. Table space defines a directory in which your data will be stored. After cluster initialization, we have just two table spaces, pgglobal and pgdefault. These are special databases. pgglobal table space contains objects from system catalog which are cluster-wide, such as pg databases table and some other tables. pgdefault contains all other objects, but you can create your own table space, specify a directory for it. Why do you need this? First of all, you can manage storage of your data on disks. For example, you can create one table space on fast SSD disks and another table space on HDD, and use them to store hot objects on quick disks and cold objects on slow disks. As you can see in this picture, databases and schemas and table spaces are different dimensions. Table spaces and schemas are independent of each other. You can have objects in one database that can be spread on different table spaces, and one table space can contain objects from different databases. So it's absolutely independent things. Databases and schemas, it's an logical organization, and table spaces is physical organization. But each database has so-called table space, so-called default table space. And by default, pgdefault is the default database, default table space for each database. Default table space is used for all objects unless you specify other table space explicitly. And also in default table space there are system catalog tables. You can create your own table space and set it as default for some database, like here. And all system catalog objects will be in this table space. And here, pgdefault is default table space, so system catalogs are here in this table space. Okay. Any questions? Yeah.
So with table space is associated with the data file?
Table space is associated with directory.
So not data file, but directory?
Directory. Data files is a different thing. We'll talk about files, I think, on the next slide. About files. pgGlobal and pgDefault, these are standard databases, and their locations are predefined. pgGlobal is always in a global directory inside your pgData, and pgDefault is always in base directory inside your pgData. And when you create your own table space, you just specify any directory you want. But Postgres always use relative paths, and they started from pgData. So when you create your own table space, it creates a link in pgTableSPC directory, which links to the path that you specified when you create your table space. And it uses this path to access your objects. Okay. Base directory is divided into subdirectories by object identifiers of databases. So objects of each database is contained in its own subdirectory of base directory. And same is true for your own table spaces, but here Postgres creates another level of subdirectories which represents version of your database cluster. It is so because it is convenient for upgrade process. And global table space is not divided into subdirectories because it contains only global objects which don't belong to any particular database. So no need to subdirectories. And inside these directories we can see files which represent each object. Each object in Postgres, say table or index, is represented by several different files. For tables there are 3 files minimum, for indexes 2 files, and so on. But you can for large objects number of files may be even bigger. So another meaning of table spaces, you can divide. Not all file systems work good when you have many files in one directory. So you can use table spaces to limit number of files in each directory. Okay, why we need 3 files for a table? Why not 1 file and so on? Each object is represented by several forks. A fork contains different type of data. There is main fork, which contains actual data that you store in your table. And there is visibility map fork, VM fork. This fork keeps track of pages which contains only raw versions that are seen in any snapshots. In other words, on such page, all non-actual raw versions are vacuumed and only actual raw versions are present. And these pages are tracked in visibility map, and this visibility map is used to optimize vacuum performance and to optimize index-only scans. And also we have free space map. It's a tree-like structure inside. It is used to track free space inside your data files. So when you need to insert new row version into table, we can quickly look up free space map and find on which page we can find enough memory for this row version. So that's why 3 files. Each file can be no bigger than 1 gigabyte by default. You can change it when you build Postgres from sources, but by default it's 1 gigabyte. So if you have more than 1 gigabyte in a table, you will have 2 files from main fork, or even more files. That's why number of files may be more than 3 per object. And another one interesting concept is toast. Postgres requires row version to fit into one page. And one page is usually 8 kilobytes. But 8 kilobytes is quite a small amount of memory. So if you have a row which is longer than 8 kilobytes, Postgres uses this toast technique. It has several options. First of all, it can compress your data so that it fits in one page. If it can't compress this data, it split your data into smaller chunks. As far as I remember, 2 kilobyte chunks, and these chunks go to special internal toast table. And when you query your row, Postgres goes into that toast table, selects all necessary chunks, concatenates them, and return your long value to client. And both methods can be used simultaneously. Your row may be compressed and then sliced into chunks. Toast table is just usual normal table, but it is created in special schema, so you usually don't see this table. It is supported by its own index to quickly find chunks that is needed. And of course, all of this happens absolutely transparently, so your application doesn't need anything about toast, but you as database administrators, of course, need to know about it, because it has some implications on performance. If you store large values in database, you have this overhead to putting them into toast table and getting them back. So very long data have its performance penalties in Postgres.
Can I change the size of the page?
Yes, we can. Page can be 8 or 16 or 32 kilobytes. No longer than 32 kilobytes.
So you can avoid the toast.
32 kilobytes is also not very big. You can imagine something that is longer than 32 kilobytes in table row. Toast table has its own versioning, its own multi-version concurrency control. So it may be good if you don't always use your long values. So if you update your row and update only fields which are not very long, you will have one entry in toast table, and two row versions from main table will reference to the same row version in toast table, so it saves you copying this data. And if you don't use these long attributes in your queries, Postgres will not access toast table and it will work efficient. This is one of reasons not to use select star in production systems. Specify only fields that you actually need. It is better. Okay, and let's see the demonstration.
One toast for all my table in the database, or
Each table,
each user table has
each main table can have its own toast table. If table contains potentially long attributes like text or number, toast table is created automatically for it. So one toast table for each main table. Okay, table spaces. Table spaces are listed in pgTablespace table. Here we can see two default table spaces, pgDefault and pgGlobal. And also you can use \db command. I don't know why B. I think it's because T is already reserved for tables, so B. It shows basically the same information. To create a new table space, you must prepare an empty directory, and Postgres must be an owner of this directory. In this example, I create tsdir directory, and then we can say create table space, name of table space, location, and you specify location of your directory. It's an absolute path to your directory. This creates new table space. Yeah.
Is there a default directory or you have to specify? Is there a default directory?
No, it's not default direct.
So I have to specify the directory name?
Yes, of course. Your table space always use some directory. Basically, table space and directory the same things. Yeah.
If I choose directory that could already contains files,
Mm-hmm.
it's not to load existing.
No. Create table space
It's
will errors or you will get an error if your directory is not empty. You cannot import some data this way to Postgres. And now we have another line and list of tablespaces. Here we can see this directory which is specified in create tablespace command. Now we can create a database and we can specify this tablespace as default tablespace for this database. It is used by tablespace clause. When you create any object in this database, it is by default created in the default tablespace. So it is TS in our case. We can insert some data into this table, create index on it, vacuum table, so on. And let's see what files we will have in the station disk. To find files which are related to some object, we can use pg relation file pass function. We pass object name into it, and it gives us relative path. You can see pg tbl spc and some digits. This is a link to the directory which we specified. Here is PostgreSQL version. Here is object identifier of test database which we created. And the last number is object identifier of your table. So we can use this path. We concatenate it with pgData, and then this path and wildcard at the end. And you can see 3 files. First file, the biggest one, is the main fork of your table. It contains data which we inserted into table by this select statement. The second file is free space map, FSM. It ends with FSM. Here it consists of 3 8KB pages. And the last one is visibility map, VM, which is the smallest one, just 1 page.
So each table has 3 files.
At least 3 files, yes. Maybe more. We can move objects between table spaces, but you have to understand that it requires physical moving of your data, copying from one directory to another. So it's potentially long operation, and the object will be locked during this operation. So some caution is required when you do this. You can use alter table set table space for this, and after this command, function pgrelation file path will show you another path. Now it starts from base because pgdefault table space is located here. We can handful of functions to query size of database, size of objects, size of table space. For example, pgDatabase size will give you your database size. And you can use pgSizePretty function to show it in human readable form, so we can see that it's about 13 megabytes. pgTotalRelationSize function shows you size of a table, including all indexes on this table. Our table T is about 5 megabytes. You can see table size without indexes and size of indexes separately. PG table size, PG indexes size.
Moving a table moves also the indexes.
Indexes can be created in different table space, but I think they are moving by default together with table, I think. We can get size of different forks. This way, PG relation.
Is index not separate file, or it's?
Indexes are different objects, so each index has its own set of forks, set of files. You can pass name of fork to pgRelationSize function. For example, you can query size of visibility map for our table. Also, we have a function to query table space size. Here it is. And so on. So you can quickly look up size of your objects. Now let's drop our database and drop our table space as well. You can drop table space when there is no object in it. If there are some objects, you can do it. You must move objects to other table spaces. Yeah.
Is it possible to import that table space to another database?
Table space and database are independent concepts. Each table space can contain data from different databases.
I mean to another cluster.
To another class? No, you can't. You can't.
And replicate on only one table space?
No. Replication works, physical replication works on cluster level. You can replicate whole cluster. Logically, you can replicate different objects, but it doesn't connect, it's not connected to table spaces. If you want to if you need to move some objects between clusters, I think we have an extension, but it's in our enterprise edition of Postgres Pro version of Postgres. And there we have possibility to prepare table and to transport it to another cluster and plug it into another cluster. But usually you can do it. You can do it just by copying files, because you have system catalog which must refer to specific files and so on. So, physically, data is stored in table spaces, which are basically the same as directories. Each object is represented by several forks, and each fork consists of one or several files. Database administrator has means to manage table spaces, but other things like layers, files, toast is basically PostgreSQL internals, and you cannot do anything to it. You can just know that it works this way. Any questions? Okay, so we have the last practice for today, and I will call Mikhail, who will say a couple of words about tomorrow.